Hello everyone, this is Navpreet and I welcome you to the online classes of Uran Institute. We are going to start a new lecture series on electronics, and we will start with the basics, and we won't go into the definitions and in a theoretical or in kind of derivation part. We will mainly be concentrating on the numericals, and it will be helpful for you for the CSIRNet, for GATE, and for other numerical-based examinations. So we will try to solve as much numericals as we can. So let's start with the very basics. So, resistance. It is nothing but a hindrance to the flow of current. Or you can say like a speed breaker that reduces the speed of vehicles, and it also looks like a speed breaker. Not exactly. So its units are ohm. We represent it like this. When the resistance is they are in series, when two or more resistance are in series, this is R1, this is R2. Then the net resistance of the circuit will be equal to R1 plus R2. If they are in parallel, here's a battery. Then net resistance is equal to reciprocal of the net resistance is equal to sum of the reciprocals of the resistance. So it will come out as so you must be aware of these formulas before. Oh, sorry. So we will do some simple numericals on it. Yes. Simply say here is a battery, and suppose this is 1 ohm, this is 2 ohm, this is 3 ohm, and this is a 6 volt battery. Then you're asked what would be the current in this circuit. So R equivalent, first we have to find R equivalent, that is 1 ohm plus 2 ohm plus 3 ohm, that is overall 6 ohm. So V is equal to IR, and I will be equal to 6 upon 6, that is V upon R is equal to 1 ampere. Similar in this case, if this is battery of 6 volt, one ohm, 2 ohm, 3 ohm. Then 1 upon R equivalent is equal to 1 upon 1 plus 1 upon 2 plus 1 upon 3, and we'll be left with 6 plus 3 plus 2. That would be equal to, we are going right? Yes. 11 upon 6, so R equivalent will be equal to 6 upon 11. So similarly, you can find I is equal to V upon R. So we are done with the resistance, but these were very simple numericals. What if you face the tough one? We will try to solve that. Here it is. Okay. So let me see the statement. Okay. And so on. So say this is 4 ohm, this is 2 ohm, 4 ohm, 2 ohm. So you have a series, the same thing, the same pattern follows to infinite number of times. So to solve such kind of questions, what you will do? You will think of there is a series of pearls in a necklace. So if we are going to add one more pearl in a necklace, then definitely it is not going to change it to a noticeable extent. So what will you do? You will take that overall resistance of this will be R equivalent, okay? Or you say R1. Say it R1, okay? The overall resistance of this. So now you will represent it like, take the whole resistance of this circuit as R1, and you just need to add one more circuit like this, because it is not going to affect the overall circuit at all. So that I treat as R1. And this is the same 4 ohm and 2 ohm. Now you have to find the R equivalent. Now, addition of one more circuit like this, addition of one like this pattern, it will not affect the overall resistance, like the same case as that of the necklace. So you will treat that R1, the net resistance is equal to 4 ohm. Now, you need to find the net resistance of these two firstly. So let's find this one first. They are in parallel. So 1 upon 2 plus 1 upon R1, say it is simply 1 upon R. So it will be like 2R1 upon 2 plus R1 is equal to R. So your net resistance will be equal to R1 is equal to 4 ohm plus the net of this, and it is 2R1 upon 2 plus R1. You just need to solve this quadratic equation, and you have to find R1. Let's solve it here. So I will take equation, and it is R1, take this denominator here after multiplying this, 2 into R1 plus R1 square is equal to 8 plus 4R1 plus 2R1. So after solving this, you will reach R1 square minus 4R1 minus 8 is equal to 0. Okay, so this is the quadratic equation, and you will find R1 is equal to, you must be aware of this, like minus B plus minus B square minus 4AC upon 2A. So we are using the same formula, 4 plus minus B square, 4 square, 16 minus, what is it? B square, 16 minus 4AC, minus and minus plus, 8 4s are 32 upon 2A, 2. So you will left with R1 is equal to 4 plus minus 48. Sorry. Yes, we are on T. And you will left with 4. Okay, so your net resistance is nothing. You just need to two plus minus 2 root 3. Now, here is the main part, like you came up with the two resistance. One is 2 plus 2 root 3 and one is 2 minus 2 root 3. But resistance is never negative. And this is definitely, it will be greater than 2. And this, 2 minus something bigger than 2 is negative. So we will omit that, and we will left with R1 is equal to 2 plus 2 root 3. you must have learned about Kirchhoff's circuit laws, like in your previous classes, and there were mainly two: Kirchhoff's current law, that is also called Kirchhoff's first law, and second one was Kirchhoff's voltage law. So we will pronounce them KCL and KVL. So what about KCL? Suppose you have a circuit like this. Take it like this, because we will solve a numerical related to this. Okay. Current flows through here, and here it will get divided. Suppose here the current was I1, here it is I2, and here it is I3. So at a particular node, this is the node, the meeting point of two or more branches. This is the node, or you can call it junction. The inflow of current at this node conventionally is taken as negative, minus I1, and the outflow of the current is taken as positive, plus I2 plus I3 is equal to 0. It means at any time t, the instantaneous flow of current at a particular junction or node will be 0, the algebraic sum of the currents. So you can simply say that I1 is equal to I2 plus I3. But while solving of numericals, we will use the convention method. We will take the inflow of current at a particular node to be negative, and the outflow of the current from that node would be positive. So this is nothing but the Kirchhoff's current law. So why are we doing this? Most of the cases, not every time, in most of the cases, when you were asked to find the voltage at a particular node, say here, you will use KCL. I'm not saying every time, but in most of the cases, you will be using KCL, because it just reduces your length of the numerical. Nothing else, it will help you to do it easily. Suppose we have we are given some values like. So you're asked what would be the resistance at point, give it a name, say it's A. You just need to find it. Use the convention if needed. Not every time, if needed. So we believe that inflow of the current will be taken as negative, and outflow at this junction, the outflow of the current will be taken as positive. So we will treat minus I1 plus I2 plus I3. This is, we are taken just for your understanding. After this, we will never take this. We will just start with V. Suppose here it is the voltage VA. So I1 is equal to V is equal to IR. So I is equal to V upon R. This is VA and this is the 10 volt. So higher minus lower. 10 minus VA upon, what is the resistance here? It's 3 ohm. 3. Here it is in negative. Okay? And here, VA minus 5 plus VA minus 5 is at higher potential as compared to this. That's why, because the flow of current is, like, we are not sure that in which direction the current is flowing, but we are treating the current like it is going in this direction, then it is splitting like this here. So VA minus 5 upon 8 and plus VA minus 20 upon, so here we have two resistance, but they are in series. So instead of taking 2 or just 1, we have to take the equivalent resistance, that is 2 plus 1, and it is 3 ohm, equal to 0. Just take it inside. VA minus 10 upon 3 plus VA minus 5 upon 8 plus VA minus 20 upon 3. Our result will tell us whether we have taken the right direction of the current or wrong. So we will see what is VA in the end. So take the LCM, 8 VA minus 8T, yes, and plus 3 VA minus 15 plus 8 VA minus 160 is equal to 0. So 19 VA is equal to, this is in minus, this is in minus, this is in minus. They will add up and we will take it to the opposite side. Okay, wait. So 19 VA minus 160 plus 180, 240, 240, 250, 255. Minus 255 is equal to 0. VA is equal to 255 divided by 19. Algebraic sum of the voltage difference around any closed loop will be 0. So in most of the cases, I'm not saying every time, in most of the cases when you are asked to find current in a loop or current through the resistance 2 ohm or 8 ohm, you will be using KVL. You can use it, you can do it using KCL, but it will make your calculations long because first you will find voltage and then you will find out the voltage drop across that resistance and then you will reach your final result. But here you will be reaching there after solving 1 or 2 equations. So this is the direction of the flow of the current, and in this loop we will take the same direction. You can take one clockwise and one anti-clockwise, but don't confuse yourself unless your mind is ready to take that confusion. V across 8 ohm and V across 5 volt battery is equal to 0. This is the overall formula, but you must be aware of the sign convention. Treat this as I1, this is I1, this is I2, this is the flow of current. So here it is okay, it is I1, it is I1, it is I2, it is I2, but what here? The current is flowing from I1 is flowing in this direction, I2 is flowing in this direction. Okay. So take just one loop. In loop 1, you're aware of this. Okay, now let's rub it. Loop 1. Minus 10 because you find the negative part of this battery first. Then V across this would be V is equal to IR. We are given resistance. So it is 3 into, what is I? It's I1. Take it. I1. Okay. So plus, what's here? I1 is going in the downward direction and I2 is coming from the upward. So the net current in this if we are taking it right, then it will be ticket. I1 is greater than I2. Just assume it. I1 is greater than I2. So I'm taking plus 8 I1 minus I2. And when you came here, you encounter the positive part. So plus 5 is equal to 0. It is 5. Plus 5 is equal to 0. So you have minus 10 plus 3I1 plus 8I1 minus I2 plus 5 is equal to 0. So, loop 2. This is a loop 2 in which you have taken the clockwise direction. You have assumed the clockwise direction of the current, and it is going like this. And we will start from here. In loop 2, we'll find voltage across 5 volt battery plus voltage across 8 ohm resistance plus voltage across 2 ohm resistance, voltage across 1 ohm resistance, voltage across 20 volt battery is equal to 0. The algebraic sum of the voltage with the potential difference in a given loop should be 0. So, we start from here. It is minus 5 plus. Take it the same way you have taken in the previous equation. We have taken that I1 is greater than I2. You have assumed this. So we will deal with in the same way. So it is I1 minus I2. I1 minus I2. This is I1. So next you find 2 ohm. It's clear that resistance here is 2 and current flowing through here is it is I2. It is I2. And again here it is 1 ohm resistance. If you want to read 1, okay. If you want to write 1, okay. Otherwise just write V is equal to IR, R is 1 and I is equal to I2. And last, we are facing the positive part of this battery. So it is 20 volt is equal to 0. So what we are left with? It's minus 5 plus 8 I1 minus I2 plus 2I2, just add them up. 2 plus 1, 3I2 plus 20. You have 2 equations, you have 2 variables, just solve them and you will find I1 and I2. I think we'll get I1 here too. Now, after solving this, you are finding I1 or I2 to be negative. It means you were taking the direction of it in a wrong way. So, if they're coming in if they're giving positive results, like I1 is say something like 3 ampere and I2 is 5 ampere, it means you have taken the right direction. The current is flowing like this. But if you're taking I1 and I2 negative, it just means your answers are right, but you have taken the wrong direction. So instead of taking clockwise, you have to just reverse the direction of this. You will be taking it as anti-clockwise. I haven't solved the equation, so I will provide you the answer tomorrow. You just need to solve them. These are simple equations. You have I1, you have I2, you have just two variables, and you have two equations here to solve. Find I1 in the terms of I2 here and put it here. You will get I2. So in KCL and KVL, in the whole series, we will be talking about KCL and KVL very frequently. So you just need to solve as many questions as you can using KCL and KVL. You have to gain the mastery in it, and it is not always necessary you will be using KCL to find voltage and KVL for finding current. In most of the cases, yes, it is. But in some cases, you will be using KVL to find voltage. So it just comes from your, like, how many questions you are solving every day. So after solving questions, you can just tell by looking at the question that what would I be using in the next phase, like KCL or KVL. Now, intelligence theorem. This is nothing. It is, you can say, the conservation of energy. If you are given a circuit, like, it will deliver some power. There will be some power associated with this, and it will be equal to V into I. There must be power associated with these two. It just means it is delivering the power and they are absorbing the power. And the overall power in this circuit would be 0. So this is what intelligence theorem tells us. So it is just a way to find out whether a circuit is true or not. Like here, if we find out current, so current will be V upon R equivalent will be equal to 3 plus 2, 5. Voltage is 5. 5 upon 5 is equal to 1 ampere. So power associated with this, 5 volt is equal to 5 into 1 is equal to 5 watt. Power associated with the 2 ohm resistance is I square R, take it, or V square upon R. We will do it with the I square R. So I square is 1 square 1, 2, so it is 2 watt. Power associated with the 3 ohm is equal to I square R, 1 square into R, resistance is 3, so 3 watt. You are starting from here. This is the delivering part. So the source which delivers power we take as negative. So it is minus 5 watt because it is losing power. Plus sources which dissipates energy or dissipates power or absorb power, we treat them as absorbing sources, and here it is 2 watt plus 3 watt. And overall it is 0. It means you have verified intelligence theorem. So you are asked to verify intelligence theorem in it. You can find, it's given that current in the circuit is 2 ampere. You can find the power of 8 volt. It is V into I. V is 8, current through the circuit is 2, it is 16 watt. Power of 1 ohm resistance absorbed by the 1 ohm resistance, it is I square R. Current is 2 ampere. Resistance is 1, so it is 4 watt. Power of 3 ohm resistance is I square into R. Current is 2 and resistance is 3. And this is the negative part of this, and it is delivering circuit. It means it is plus and it is minus. So it is minus 8 volt plus 1 into I. We should take this direction as like this, because it is given that the current in the circuit is 2 ampere and it is going like this. So we will take it as positive. It's 3 into I, that is 2. Voltage across 2 ampere. But here it is, we are encountering the negative part first. So we will take as minus. And the voltage across 2 ampere current element plus 1 into current in the circuit is 2. So take V2 on the other side and we will left with 3 2s are 6, 6, 6, 12, 16 volt. So voltage across this is 16 volt. So what would be the power? So power of 2 ampere current element is V into I. We know V, 16, and current is 2 ampere, and this is 32 watt. This is the delivering source, and these all are absorbing the power. So add them up. 12 plus 4, 16, 16 plus 16, 32 watt. And here it is P2A, the power of the 2 ampere current source is 32 watt. They are equal. It means it is dissipating the energy and they are, it is delivering the energy and they are absorbing it. It is 2 ohm, it is 3 ohm, this is 9 ohm, and this is 6 ohm. And you have, this is 15 volt battery and this is 21 volt battery. You have to find the current through every resistance. Oh, okay, let's make it simple. You will take, suppose you are taking this direction. Here is, this is I1, this is I2, this is I3. You have to take the current through 3 ohm, current through 9 ohm, and current through 6 ohm very carefully, because it must be like I1, if you're taking I1 is greater than I2, I1 minus I2. If you're taking I1 is also greater than I3, then I1 minus I3 for this resistance. And for this, you will be comparing I2 and I3. You must be taking I2 minus I3 or I3 minus I2. That's your convenience. So you have to find I1, I2, and I3. 3 loop, you will get 3 equations. You have 3 variables and you have to solve them. You are using KVL. Okay, the second one is, this is your numerical, and you have to find VA using, you are using here KCL. While applying KCL, like, always make sure in your mind that you are taking the direction of it right. Like, you are using the conventions. Like, here it is going inside the junction, so you have to take it negative. And while solving this, it's on you. You just start with VA minus this upon this, VA minus 20 upon the overall resistance. And because you cannot compare the voltage and voltage of this, you just taking the inflow of current. Okay, let's just make an equation. How we will do this? VA minus 10 volt upon overall resistance is, what is the resistance of this? It's 3 ohm. 5 plus 3, 8. I don't know what is the voltage here, but I know they have given me a current element, and this is KCL is about taking the algebraic sum of the current is equal to 0 at a junction. So we have given a direct current. So instead of dealing with voltage or resistance, I will taking as, because it is the inflow, I will take -8 plus VA. Here it is minus. You have to take it minus also. VA minus of 20 volt upon 2 plus 1, 3 is equal to 0. This is how you are going to find VA. VA minus 10 upon 8. Normally we take VA minus, here some voltage is given, divided by resistance. But we are not given voltage and we are not going to find it. We know it is all, KCL is all about current. Because we are not given current, we are dealing with the voltage and resistance. But here it is given current. So we will take the inflow of the current as negative and we will directly put the value of current as 8. And VA minus, here it was plus, here it is minus. You are facing the minus part of it. So VA minus of 20 volt upon 3. And you have to solve it to find VA. Okay, let's give you another numerical like this. Let me see if I have. Yes. So here it is current element. Let us make it a little, here it is minus plus. And we will give it a so take it as 5 volt, another thing, 6 ohm, 3 ohm, 2 ohm, 7 ohm, 3 ohm, 5 and 1. It is 20 and this is 9 ampere current volt and this is 10 volt. And you have to find, say this is VA and say this is VB. Here you will get two equations. You will be doing like this: VA minus 5, so it will be VA plus 5 upon 9, VA minus 10 upon 2, VA minus VB upon 7 is equal to 0. Then we will come to the next junction, VB minus VA upon 7, VB, no, here it is not voltage. Instead of taking VB, we will just take minus of 9 ampere and VB minus 20 upon 6. So you have to solve two equations and you will get VA and VB. You have to find out the current through the circuit and you will verify intelligence theorem. And how will you find current? You will be using KVL. In most of the cases, whenever you have to find current, so firstly think about KVL. Take any direction, go with this, minus 20 plus 2 into, say this is current I1 plus 40 plus 4 into I1 is equal to 0. You can find I1 and then you have to verify intelligence theorem. And the last question is, you can try it at your home. This question 4. But you will be needing a new concept, like if you are aware of Wheatstone bridge and delta star conversion, not exactly the Wheatstone bridge. You can try with the Wheatstone bridge, but you won't reach the answer. So you have to use delta star conversion. If you are aware of this, okay, otherwise we will attempt this question in our next class, but try, at least try. That's not needed. You just need to find R equivalent. This is 9 ohm. This is 3 ohm. This is 4. These are in ohm. 3, 6. Oh, I'm so sorry. Okay, this is 3. 9. Okay, yes, you have to find R equivalent. Just write at your home. So we will discuss in the next lecture. So see you in the next lecture. Till then, stay safe, stay happy.